Welcome to math classes by MDR. So that you are listening to MDR. So here is the sixth question from AP Calculus AB 2021. So here is the data given. A medication is administered to a patient. The amount in milligrams of the medication in the patient at time t hours is modeled by the function y is equal to a of t that satisfies the differential equation dy by dt is equal to 12 minus y by 3. At time t is equal to 0 hours, there are 0 milligrams of the medication in the patient. So now the question here, we have as well 4 parts of question we have. So here the first part, a portion of the slope field for the differential equation dy by dt is equal to 12 minus y by 3 is given below. Sketch the solution curve through the point 0, 0. So point 0, 0 we have here at y is equal to 0 dy by dt is 4. So that, and then the slope is decreasing and it goes and it approaches up to 12. Right, where it is 0, right, where dy by dt is 0 at this point, so that it is the point 12, where y is equal to 12, dy by dt tends to 0, so that this is our curve, right? So the first part is done. Now let's go to the second part. Use the correct units, interpret the statement limit t tends to infinity, a of t is equal to 12 in the context of this problem. When t tends to infinity, a approaches to, and t tends to infinity, a of t approaches to 12, it means that a maximum of 12 mg. It means that, what is a here? The amount of medication, right, that in milligrams, amount of medication in milligrams. So a maximum of, when t tends to infinity, so you can write in 2 ways. The medication, okay, the amount of the medication in the imparted in the patient, the amount of medication imported in the patient is 12 mg, is 12 mg. Maybe you can write in other ways, a maximum of 12 mg can be imported in the patient's body, okay, irrespective of the time, that is, even though that time tends to infinity. So that's the answer for the second one. Now let's go with the third part. So use separation of variables to find y is equal to a of t, the particular solution to the differential equation dy by dt is equal to 12 minus y by 3 with the initial condition a of 0 is equal to 0. That means at t is equal to 0, y is 0, right? So let's do the separation of variables. We have dy by 12 minus 5 and dt by 3. Integrate on both the sides to get the solution of this equation. So I think I better take this y minus 12 instead of 12 minus y. I would prefer to take y minus 12 here, so that makes our problem easier. So y minus 12, so that we'll have negative sign here. Okay, so the left hand side I have exchanged these signs, so that the right hand side also we have negative. So we have ln of y minus 12, which is equal to minus 1 by 3 into t plus a constant. Right, now take the exponential both the sides. You will have y minus 12 e power minus 1 by 3 t plus c. In other words, we will write as e power minus 1 by 3 into t. So now we can determine the value of c by using the initial condition given here. So what is the initial condition? At time t is equal to 0, y is 0. So by using that, we have minus 12 and then c into e power 0, so that c is equal to minus 12. Therefore, the particular solution to the differential equation is y minus 12 is equal to minus 12 e power minus 1 by 3t. So you can make y the subject, so that y is equal to 12 minus 12 into e power minus t by 3. That is the answer for the part C. Right? Now let's see the fourth part. A different procedure is used to administer the medication to a second patient. The amount in milligrams of medication in the second patient at time t was modeled by y is equal to b, that satisfies the differential equation dy by dt is equal to 3 minus y by t plus 2. At time t is equal to 1 hour, there are 2.5 milligrams of the medication in the second patient. If the rate of change of the amount of medication in the second patient increasing or decreasing at time t is equal to 1. So how do we how do you answer this question to find out increasing or decreasing at time t is equal to 1? So we have to find out the rate of change of amount of medication, right? So that we have to take the rate of change of amount of medication over that is the second derivative. If the second derivative is positive, then it is increasing, the rate of change of amount of medication is increasing. If it is negative, then it will decrease. So let's see that. So this is 0 minus y by t plus 2. So I will take it as dy by dt and into t plus 2 minus t plus 2 is 1 plus 0 into y, okay, by t plus 2 whole square. So now let us substitute the values of t and y here. What is the t and y? So t is 1 hour and y is 2.5 milligrams. So on substituting this, so dy by dt also you can take. I am taking here dy by dt. Maybe let me substitute here directly. That is dy 3 minus y is 2.5 by t is 1 plus 2. So this is 3 minus 2.5 by 3. So 3 minus 2.5 by 3. T plus 2 is 1 plus 2, that is 3, minus y is 2.5 by 3 square. 1 plus 2 square is 3 square. So which is, so what we have, it is 9 minus 2.5. When you multiply this with by 3, we'll have 9 minus 2.5. So minus 2.5 by 9, which is equal to 9 minus 5 by 9, which is equal to 4 by 9. And we should carry this negative sign over here. And it will show us it is minus 4 by 9. That is a negative number which is less than 0. So it means that d square by dt square is less than 0, means that the rate of change of the amount of medication is decreasing at t is equal to 1. That is your answer. Okay. Thank you for listening.